Hi everybody, so today we're going to talk about stoichiometry and we're going to make it really easy and simple for you to understand, and we're going to talk about specifically the type 2 reaction question of stoichiometry types of questions basically. So we're going to talk about type 2. But before we start, I would like to clarify the difference between a type 1 and a type 2 question before you start, because when you get a question you need to be able to know if it's a type 1 or type 2 question before you start answering it. So, the difference between a type 1 and a type 2 question is that a type 1 question will give you the mass of one reactant. Only one reactant. So it will give you the mass of only one reactant in the question. And then a type 2 question would give you two or more, will give you the mass of two or more reactants. So basically that's the difference. So type 1, it will only have one, and then type 2, it'll have more than one basically. Okay? So this is what I'm gonna be talking about today. Okay. And I'll be using, because there's more than one way of solving a type 2 question, but I'll be using this one right here. But there's two ways actually. One of the ways is, the chart here where you put the before and then during and then after, and you put the reactants on one side and then the products on the other side. Yeah. And you put the products on the other side. And the other type, which I'm going to explain today, is really easy. It's basically using the type 1 method more than once to answer a type 2 question. And usually it's just twice. Yeah, so that's what I'm going to explain. Okay, so this is the one I'm going to explain today, not that one. So if we have this type of questions, like a standard type of type 2 reaction stoichiometry thing, okay, it says here, if 200 grams of propane are burned in 20 grams of oxygen gas, what mass of carbon dioxide is formed? Okay, and they give you this equation right here. Okay? So, before we start, I would like to show you the really simple steps to answer these types of questions. And here are the steps. Okay, first step, you balance it out. The equation needs to make sense. Okay, so you balance it out before you start doing anything with the equation. And then the second thing is you need to find the limiting reagent. And you find that out using the type 1 method, okay? And then third thing is, after you find the limiting reagent, you use it, you connect it to what the question wants using the type 1 method again. It's only 3 steps. It's really easy and really simple, okay? So we'll do the first step first, okay? Which is balancing the equation. And we'll go back to the question. Here it is. And we need to balance this out because it's not balanced. It says there's 8 hydrogens when there's only 2 on the other side. And yeah, so it's obviously not balanced, and we need to balance it out. So let's balance it out here. Okay? First things first, we look at the easy way of solving this, balancing it out, is you look at the biggest number, and there's an 8 here. So 8 hydrogens on this side. So we need to have 8 on this side, right? And there's only 2, so 2 times what gives you 8? 4, so you put a 4 right here. And you look at another big number and you find a 3, right? Okay, so there's 3 carbons. And then on the other side, there's only 1 carbon. So what do we need to do? We'd put 3 carbons, okay? But now we kind of messed up the equation for oxygen, right? Because we added a 3 and 4. Anyway, it wasn't balanced in the first place. But yeah, so how many oxygens do we have on this side and on this side? So we have 2, right? And then we have how many here after we put a 3 and a 4? Okay, so 3 times 2, we get 6. And then 4 times 1, we get 4. So we have 10 oxygens on this side and 2 here. So what do we need to do to this 2 to get 10? So 2 times what gives you 10? 5, right? So we put a 5 right here. Now everything is balanced. So this is our balanced equation. And we already finished the first step to answering this type of question. Okay, so the second step is to find the limiting reagent. But what exactly is their limiting reagent like? How does this make any sense and stuff? So I'm going to explain the limiting reagent using a type of example, analogy kind of thing. Okay? So, you have 3 apples and you have 8 oranges in your fridge or something. Okay? And you want to make baskets of 1 apple and 2 oranges. So each basket has to have 1 apple and 2 oranges. How many baskets can you make out of the stuff that you have in the fridge? Okay, so let's do this one step at a time to explain the concept, right? Okay, so here we go. There's a basket right here. It looks ugly, but okay. And yeah, so we need 1 apple. We put an apple here. Okay, well, there you go, an apple. And then we need 2 oranges, right? Because each basket has 2 oranges. So we put 2 oranges. And we need to cancel out what we use. Goodbye and goodbye. Ugh. Okay, and then we can still make another basket, right? Yeah, we can. So we'll make another basket. There we go. We make another basket. And then we need an apple. Put an apple. And then we need 2 oranges. We put 2 oranges. Cancel out what we used. Blah, blah. Can we make another basket? Yes, I think so. So we make another basket. Blah. Okay? And then we put an apple. There you go. And we put 2 oranges. Cancel out what we used. Blip. Oh, wait. There you go. And there you go. Now, look at your fridge. There you go. Can you still make any more baskets? I don't think so, right? Because there isn't enough apples left. There's no more apples left to make a basket. But there's still like 2 oranges left, right? But you still can't make a basket. So what stopped me, what limited me from making more baskets? The apples, right? The apples. Apples stopped me from making more baskets. So basically, if this was a chemical reaction equation thing, the apples would be the limiting reagent. So that's what a limiting reagent is. It's something that's used up completely, and this is the excess one because there's still stuff left, even though the limiting reagent is used up. It's what limits how many products, baskets, are made. Okay? And yeah, so we need to find out what the limiting reagent, because once you know that, okay, the apples are the limiting reagent, okay, we can easily find out how many baskets you can make with these apples. Because, okay, if you have 3 apples, and then for each basket you only need 1 apple, so that means, oh, okay, so 3 times 1, and that gives you 3 baskets, because you only have 3 apples, and each basket needs 1 apple, so you are able to make 3 baskets. Okay, so that's why, so this is what a limiting reagent is, and why we need to find the limiting reagent. So we are able to make the connection between the limiting reagent and what the question wants, which is how many baskets. Okay, so we'll do the second step with the question that we have. Okay, so we balanced it out here. Okay, so I'm just going to move this question and rewrite it so you have more space. And I'm going to put it here. Okay, it's all balanced out here. And I just like changed the layout of the question. I just wrote it simply. So you have 200 grams of propane and 20 grams of oxygen gas. And then how many gas of carbon dioxide do you get, right? Okay, so we need to find out which one of these two are the limiting reagent. Is it the propane or the oxygen gas? Which one will limit how many carbon dioxide is made? Okay? Which one will be completely used out, and which one will have still like stuff extra? Which one will be completely used out, and which one will have still some stuff left behind? Okay? So how we find this out? using the type 1 method. Okay, so I'm gonna pick one of these. Okay, because remember in the type 1 method, you would, choose what's given. You would always have to put what's given first, right? But in this type of equation, we'd have more than one mass of one reactant given. So it doesn't matter which one you choose, but I'm going to choose the first one, okay? So I'm going to put 200 grams of propane. I'm just going to put P, okay? Yeah, of propane times 1 mole of propane. Okay, and then here you need to put the molar mass of 1 mole of propane. So, using the periodic table. And I already did that, so that's 44 grams of propane. Okay, yeah, so remember this from the type 1 method. Remember, you need to convert the grams to moles because the only connection we have is moles in this equation. Okay, and if you don't remember, please watch the previous video to clarify and for everything to make sense. Okay, so and then you need to put the ratio of the two things that we're comparing. Okay, we're comparing this one and this one. You want to find out which one is a limiting reagent. Okay, so basically what we're going to do here is what we're trying to find out what this means, what we're going to do, it means that if I have 200 grams of propane, how many grams of oxygen gas do I need for the 200 grams to be used completely? Okay, so that's what this equation that we're going to do here means. So we need to put the ratio of the propane and the oxygen gas. So, to cancel out the propane, so we need to put the propane here. So how many moles of propane do we have? We have one mole of propane. And then how many moles of oxygen gas do we have? We have 5. Okay, so we have 5 moles of oxygen gas. Moles of O2. Okay, and then we need to convert the moles to grams. Okay, so this is canceled out. We need to cancel out this, so we need to put 1 mole of O2 is how many grams? 1 mole of O2 is how many grams? It's 32 grams, using the periodic table, okay? Is 32 grams. Okay, and then so now this is canceled out. This is canceled out, and then you get, after you do 200 times 5 times 32 divided by 44, gives you 727.27 grams of O2. Okay, so look at this number right here, 727.27 grams of oxygen gas. Now we have to look back at the question. The question says we only have 20 grams of oxygen gas. Okay? So what does that mean? It means that, wait, we don't have 727 grams of oxygen gas for the 200 grams of propane to be completely used out. So that means the propane is not going to be completely used in this equation. So what does that mean? If something is not completely used, it means it's the excess, right? That there's going to be stuff left behind because we don't have 727 grams of oxygen gas for this to be completely used. So that means the propane is the excess reagent and the oxygen gas has to be the limiting reagent. Okay, so now we found out the limiting reagent. Okay, we found it out. It's oxygen gas. So we did the second step using the type 1 method. Okay, so we're done. we've done the first step, we balanced it out, we found the limiting reagent, okay, by using the type 1 method. And then now once we have the limiting reagent, we need to do the connection between the limiting reagent and what the question wants from us. Okay, like the what's it called? The apples and the oranges. You know, once we found out that the apples were the limiting reagent, we did like 3 times 1, you know, because there's only one apple. I mean, like, because the question's asking how many baskets can you make, right? So if you have 3 apples, how many baskets can you make if the baskets need 1 apple each? 3 baskets. So you know this connection, you know, between the limiting reagent and the question. You forget about the oranges. They don't even matter, okay? Because they're not the limiting reagent. There's like extra oranges, so it doesn't matter. Okay, so that's what we're going to do here. Yeah. Okay, so now we found out the limiting reagent. So we do a type 1 method again, okay, by using the limiting reagent. Okay, so we have 20 grams, see, 20 grams in the question, 20 grams of O2, okay. We need to convert it to moles. We always need to convert it to moles because we can't do anything with grams because the only connection we have between the oxygen and the CO2 is moles, okay. So we need to convert it to moles. So 1 mole of O2 is how many grams using the periodic table? It is 32 grams, right, of O2. Okay, now we need to do the connection between the oxygen and the CO2. What the question wants, because the question is how many grams of CO2, right? Okay, so now we need to do the connection between that, between the limiting reagent and what the question is asking of us, which is the CO2. So this cancels out, and then we need to cancel out this, so we put the moles of O2 on the bottom. Okay, but how many moles of O2 do we have in this equation? 5. So 5 moles of O2. And then how many of CO2? 3 moles of CO2. Okay, so this cancels out. And then now we need to change the moles back to grams because the question is asking how many grams, not how many moles, how many grams. So we need to change the answer to how many grams. Okay, so we need to cancel out moles of CO2, so you put moles of CO2 at the bottom. Okay, moles of CO2. For each 1 mole of CO2, how many grams are there in each mole of CO2 using the periodic table? And that is 44 grams of CO2. This cancels out. There's no space here, so I'm just going to write it here. So what you put in the calculator is this, 20 times 1, but I'm not going to write that. So 20 times 3 times 44 divided by 32 times 5 equals, so I put that in the calculator and I got 16.5 grams of CO2. Okay, so you multiply everything on top, everything on the bottom, just like type 1 method, okay? And guess what? This is your answer. Well, yeah, 16.5. That's your answer, okay? You're finished, you're done, okay? You followed the 3 simple steps, you balanced it out, you found the limiting reagent, and then you use the limiting reagent to what the question wants. Okay, so I'll just walk you through it again. You balance it out, you're done, first step. Second step is to compare the 2 reactants, the 200 with the oxygen. Choose any one of them first. I chose the first one, so I put 200 and then convert it to moles, put the connection between the O2 and the propane, and then I converted the moles to grams. I found out that you needed a lot more than what we have to completely use the 200 grams of propane. So that meant that what's it called? That the propane is the excess agent and the oxygen is the limiting reagent, because we're not going to be completely using the 200 grams of propane, because we can't, because we don't have that much of oxygen. So that means we're not going to use 200 grams completely, and what that means is that there's going to be stuff left behind, and when there's stuff left behind, it means it's the excess reagent, not the limiting reagent, because the limiting reagent has to be used completely. Okay? And then so we found out the limiting reagent, and then we use the limiting reagent, convert it to moles, and use the ratio of how many O2 for, using the connection between the oxygen gas and what the question wants, which is the CO2. And then we converted it to grams, okay, because the question asked how many grams. But if the question asked you how many moles, you wouldn't actually need to do this step. You would just, it'd finish. It would actually be like, bye, go away. And then you'd only do this part, and that's it, because your answer would be in moles. But if it asked you in grams, like it did here, you would need to do this step. You need to convert how many grams are there in a mole. Okay? So, so that's your answer. You did it. It's really easy. Okay, and I'd just like to show you maybe if you get a different type of question, or they'd ask you 2 questions in a question, like how many grams of CO2? Okay, we did that. But then what if they also ask you how many grams of water is formed? Don't freak out, okay? It's really easy. So you'd found out already the CO2, right? How many grams? But what if they said, okay, we also want you to find out how many grams of water would be formed too, with the same, amount of stuff, right? Okay, so what you do, you'd use the limiting reagent again. You'd basically do the same thing, but you just change, instead of the CO2, you'd put the hydrogen stuff, okay? So, for example, here, you wouldn't put 3, I'll just change the color for you to see easier. Okay, so instead of 3, you'd put 4, because there's 4. And then you change this to water, H2O, sorry. And then, you change this into H2O. Sorry, it's really messy, but yeah. Okay, H2O. And then for each 1 mole of H2O, how many grams are in that? And you'd put how many? I think that is 18 grams, I think, off my head. Yeah, I think that's 18. 18 grams of H2O. And then you do the same thing, multiply the top numbers by the bottom numbers. So you change this to 4, and you change this to 18, 24, 18. And then you change the bottom with, you don't even need to change the bottom. Yeah, you just leave it like that, and then the answer changes. I don't know what the answer is, but if you put it in the calculator, you'd get like a different answer. Okay? And you'd get something grams of H2O. So you can do that. So if the question, asks you more than one thing, you don't have to like freak out or whatever. You'd still like balance it out, find the limiting reagent, but you just have to do number 3 more than once, the step number 3 more than once, because the question's asking you for not just one thing, for 2 things. And yeah, that's it. It's done, and I hope you find it really easy, because it is. So yeah, and inshallah this helped you, and you guys do awesome on your exams, and I hope you do really well. Bye.